Thanks for joining us. So the title of this very short 10-minute session is "Can you beat the system?" And so what we're actually going to do is do 2 minutes on what we are actually showcasing, which is a product called Sextant. So Sextant helps you spin up Sawtooth environments, Sawtooth networks on Kubernetes in the cloud. We happen to be using AWS for this. But then you've probably heard an awful lot about the frameworks themselves, but what's really fun is actually then trying to run what, in the case of Sawtooth, is called a transaction processor. And so we're going to run one of the stock demos called tic-tac-toe, which is noughts and crosses. And the idea is to use this as a way of demonstrating how, on the back end, the transaction processor is making sure you don't do things like double spend or the equivalent in tic-tac-toe, which is to play one move after the other, that kind of thing. But anyway, that's what I'm about to show you. So having said that, super briefly, what we're about is creating a curated version of or distribution of Sawtooth. So this is a classic professional open source support model where we build, test, and maintain a version of Sawtooth. And so we're at 1.05 at the moment. Now 1.1 was announced last Friday. That means we're currently going through the whole sort of testing process before making that available. So it's really aimed at making sure that you're dealing with a known version of a piece of relatively complex software. But if that was all we did, it would be useful. But in addition, we then provide you with a nice, easy, graceful way of then deploying it and spinning it up in terms of a runtime environment so that you can then experiment. So this notion of one-click deployment we talk about a lot. It's the idea of taking all of the pain and strain out of actually standing up a Sawtooth network so you can actually start doing something useful with it. Because at the end of the day, what nobody will admit to is this is just middleware, right? I mean, it's a different kind of middleware. It has some interesting characteristics that differentiate it from other middlewares you may have worked with in the past. But middleware is only as useful or as valuable as the applications and services that it can support. So, essentially, let's get you to the point where you can be productive, actually use these frameworks. And that's true not just, by the way, of Sawtooth, but of the other frameworks within the Hyperledger community. So there's a sort of direction of travel, which if you were in the talk we gave this morning, we went into this in more detail, but the direction of travel for the community as a whole is that we're actually looking at Kubernetes as the standard or default runtime environment for all of the frameworks and all of the tooling. And that makes sense because everything we produce at the end of the day is a set of Docker images in some repository somewhere. So then deploying those, standing those up, Kubernetes is a very logical choice. It's also available on pretty much any cloud if you want to experiment. So nowadays, Kubernetes is a supported service on all the major cloud providers. Anyway, end of spiel. So if that's the case, now let's look at here is I've logged in. You can see we've been deploying a whole bunch of different environments. So some, it says, are purely created. What does that mean? If I drill down on that, that means that we have here a Kubernetes cluster and in classic cooking terminology, it's one we stood up earlier. It takes 5 to 10 minutes to stand up. So now we can then go in and actually specify the Sawtooth configuration. We're going to make this a standalone, so it's going to have its own Genesis block. We're going to go with the Poet. We're not going to put in any custom TPs, but we will enable the tic-tac-toe transaction processor and then deploy. Excuse me one second. Okay, so what's happening now? As you can see, if you unpack Sawtooth, it has the notion of a validator. So a validator is a node in the network. So you get a Sawtooth network consists of a network of validators. In addition, we have a monitoring service, which we're not actually going to use right now, but that that lets you then introspect what's actually happening under the covers. So it uses something called InfluxDB and Grafana to visualize that data. So that gives you a sort of a way of introspecting what's happening on Sawtooth. But what we're more interested in doing is actually playing tic-tac-toe. So at the moment, it's bringing up the validators. What does that mean? That means that we're basically, in Kubernetes terms, we're taking a manifest that describes the actual configuration we want. So we've got a 3-node Kubernetes cluster. We want to run a validator on each of those nodes. As soon as that comes up, which hopefully we'll do in the next couple of minutes, we then have a live running Sawtooth environment into which we can then interact with the tic-tac-toe demo. So I'm just going to check to see whether there's one we made earlier on this as well. So when was, oh, it's actually done it. Was it? No, it's still working. Demo 2, right. Thank you. No. Right, so this one we fired up a couple of hours ago. So if we now open the, so this is basically, hands up who knows how to play tic-tac-toe. It's probably the easiest question you've been asked all week. Okay, well, some of you know, and the rest of you are refusing to admit that you've ever played noughts and crosses. So what we're going to do is we're going to create a game. So let's think about what's happening here. This looks awfully like a standard client app. Well, guess what? That's because it is a standard client app. However, what it's doing is it's going to interact with, on the back end, the server side, a thing in Sawtooth called a transaction processor, and we're going to ask it some very simple things. We'd like to create a game, so hold my breath. Okay, never work with children, animals, or CEOs when it comes to demos. I've managed to freeze the entire thing here. All right. When in doubt, bail out on that guy. Come back to this guy, which hopefully has deployed by now. Yes, right, let me start again. This is talking to a completely separate Sawtooth network. So the beauty of this is I can have as many of these as I like. So when one doesn't work, throw it away, start another one. Probably not a good advert for... Okay. All right, victory. I will now quit while I'm ahead. I've now created a game. Unfortunately, though, it's not a very interesting game just now because no one's made a move. So let's take a step back. What are we doing here? This is really being used really to just teach people some of the basic concepts. So I have a client. That client lets me initiate transactions. In this case, create a game. It also lets me take spots. So what just happened there? So now, by the way, you could play tic-tac-toe without a blockchain underpinning it, but what's actually happened is we've now sent in a request saying, we would like to initiate this game. I'm player 1, so I'm going to take, this is cell 1. So the instruction that went over was basically to just take that space. I'm now going to switch and be player 2. And you'll notice here it's telling me, so far it only knows about one player. So all of this state is being stored on the chain. But player 2 is going to come in and grab the high ground there. Give it a moment to refresh. Interesting. Okay, so can you see what's happened here? So although this is a terrible demo, I freely admit it, hurrah, it's called up. So I attempted to take the same space again. So even though my client genuinely thought that that space was available, on the back end, the transaction processor is maintaining the state of this game and already knows that even though the information hasn't flowed back to the client, that space has already been taken. Likewise, if I stick with the same player, so this is player 2, and I try and take another move, again, it's saying, if you can see top right, not this player's turn. So you could, of course, implement all of these rules in a front end, but what we've done is create a very naive front end that says, what I'd like to be able to do is cheat. So I'd like to be able to, take a space that's already taken. I'd like to make a move when it's not my turn. And at every step along the way, what's happening is, those transactions, when they come through, are being compared with the state of the world as understood by the blockchain. And clearly, tic-tac-toe is a kind of naive example, but if we continue to play, now it's happy because we're now back on turn. But if I try and take a double spend, are you all familiar with the concept? It's spending the same money twice. Here it's making this, it's essentially saying, I want to, make 2 moves rather than 1. The interesting thing here is that, we are ensuring that you cannot beat the system. Any questions? Stunned silence. There are other uses for blockchains beyond playing tic-tac-toe, but it happens to be a fun one. So thanks. Oh, there's a question at the back.
Yeah, so my limited understanding was POET originally required the Intel hardware, but now it doesn't. Is that correct?
Yeah, there's now 2 flavors. There's POET SGX, which does require the underlying hardware, and there's POET, the proof of elapsed time, which is a generalization of that does not require the Intel chipset. So we've moved on from when it was Sawtooth Lake and it was originally contributed to the community. That was very much the focus. Proof of elapsed time was geared towards SGX. So now you have 2 flavors, one with and one without.
Can I get this is a naive question, the 30-second comparison on why you might use Sawtooth over Fabric? 10,000-foot view, 20.
I love that question. I've been asked it for the last couple of days. The simple answer is the modularity of Sawtooth, the fact that it is extremely simple. If you look at the number of components, there are validators. There is a network of validators. Each validator has a number of transaction processes hanging off of it. You've got the clear separation between the network, which looks after the global state, and both the state of the world and the history, and the TPs, which are at the application level and are completely separate. So you can take your existing knowledge, experience of things like client-server development and apply that directly. So the only thing you've got to think about is the state model and making sure you understand what should be stored on-chain versus what does not need to be stored on-chain. But it's a very simple, very clean application development model. And then the final thing is there is first-class support for Solidity and for WebAssembly, which is built into Sawtooth. So you've got the Sawtooth Ethereum integration Seth, and you've got Sabre, which is the WebAssembly support. So I think overall it wins because of the elegance and simplicity of the underlying architecture and the separation of concerns between the network layer and the application tier.